Hello students, welcome to the first tutorial in the free fall series. In this tutorial, we're going to look at how we approach questions to do with free fall. We'll start with a simple description of what formulas we use and how free fall relates to linear motion. And then after that, we'll quickly jump into a question to see how exactly we can apply this basic concepts we described to work out a real question on free fall. Okay, so the question we're going to work out is going to be this question. You guys can try it out. But before we come back to this question, let's just look at a few things that you need to keep in mind when you're dealing with free fall. Okay, now with free fall here, we're basically just describing objects which are falling or which are moving in air under the influence of gravity. So this is going to literally be vertical motion. It is an extension of linear motion, but this is now linear motion in the vertical axis. So what is happening there? Well, free fall can be looked at in two ways. It can be that an object is falling from some height, coming all the way down, vertically downwards, or it can be an object being thrown to go vertically upwards to some maximum height. And then maybe you might be asked to also evaluate the motion as the object starts coming down. So here in this case, of course, what we're saying is for the parts where the object is moving freely in air, influenced only by G, this part is the one where we are describing as free fall. During this part, where only gravity is interacting with the object, we are saying that this object is falling freely. So maybe if you think about it going up, you might say, hey, it's going up. It's not really falling. But to maybe help you understand, you can even just look at this part where the object is just falling straight downwards. But basically with free fall, we just want to see the influence of gravity on the motion of objects which are moving in air. So again here, we're taking air resistance to be negligible. So just like I said, this is an extension of linear motion. So we'll still be using the equations we saw in linear motion. So I'm just going to quickly just list them down as we are going to use these equations. So that's ut plus half at squared. And lastly, we v squared is equal to u squared plus 2as. Okay, so with free fall, what we're keeping in mind here is the acceleration present. This is going to be due to gravity. So the acceleration will be equal to gravity, and gravity always points downwards. So we'll be using gravity as negative 9.8 meters per second squared. So this is going to be our gravity. Now, one other thing that I just want to point out in these equations, of course, v is the final velocity, u is the initial velocity, t is the time taken, and then s here is the displacement. Sometimes we use it as a distance, but of course, in most cases, we use it as a displacement. Okay, so with that in mind, of course, this s here is also the same, so this is also going to represent displacement. Okay, now what are some of the common tricks that you have to keep in mind when you're dealing with free-falling objects? Well, the most common one is the velocity at the maximum point. So if an object is thrown to go vertically upwards, what you always have to remember is they won't tell you this every time in the question, but they expect you to know it. At the turning point, or at the maximum height the projectile will reach, at that particular point, the velocity will be equal to 0. Come on. This is even the reason why the projectile turns to start coming downwards. So the velocity at the turning point will be equal to 0. So regardless of what velocity you throw it with, provided it has reached its maximum height, just before it starts coming down, the velocity at that particular point is going to be 0. This will be helpful in so many ways. Okay, next up, if the projectile is thrown to reach that level and it starts coming down, you see, the time it takes to go up from this same level and the time it takes to come back down to the same level, let's say that's t1, provided it comes back to the same level where it was thrown from. In this case, if that's the case, then t1 will be equal to t2. So in this case, if you wanted to find exactly how long the projectile was in the air or the object was in air, all you have to do is the total time will be equal to either just add them, but because they're the same, all you need to do is just find T1 and then double T1. When you double T1, what you get is going to be the total time this object was in air. Okay, then other thing that might be helpful to you is if you were to throw it with a velocity here, let's call it v, an initial velocity v. So as it goes up, on its way down, as it reaches the same level, this object will have the same velocity as the one you threw it with. But the difference is in the first case, it was going up. In the second case, this velocity is a downward velocity. So it is going to be negative. These are just common things that you're expected to know when it comes to dealing with free falling objects. Now, there's so many things that we can describe here, but those are the most important ones. Now, before we start looking at the question that I showed you guys there, let's just look at one important thing. This is a question that you expect to find when it comes to maybe multiple choice questions. But if I was to draw a velocity time graph for a freely falling object, what you guys expect to see is that for a free falling object, gravity is always constant. Gravity will always be that negative 9.8. There's nothing that, the object is going down this time, so gravity is going to be positive, or maybe the object, when the object is going up, gravity is going to be positive. Gravity is pointing down. So if you're going to take down to be negative and up to be positive, then you expect gravity to always be negative. So let's say if you throw an object with a certain velocity here, let's say v, what will happen is that as the object is going up, its velocity is reducing, but because it is reducing due to gravity, and gravity is constant, so we expect the reduction in its speed to be a linear reduction until when it reaches the maximum height. So at this point, what we expect is that the object has reached the maximum height. You can even label this point as T1, the time it took to go all the way up to the maximum height. And next up, the object now starts to come down. So let's say if this is, you can even remove this for now. So the object now starts to come down. As it is coming down again, we're saying it's the same gravity influencing the fall. So meaning we expect the fall again, or the velocity to be increasing linearly. So we expect to see a continuous linear line all the way from there. Now see, the graph now comes downwards. Why? Because this is velocity. At this point, where this graph starts coming down, all that is happening is that the object is now coming down. So the values of velocity are now negative from the turning point. At this point, this is our turning point. The object is now coming down, so the velocity is now negative. And by the time it reaches the same point where we projected it at, by the time it reaches that point, let's say at that point, once we are at this point, we expect the time here to be double whatever this T1 was. This is what I was saying. The time it takes to go up will be the same time it takes to come down. So to get the total time for going up and coming down, just double your T1. So the time here will just be double T1. I'm using double because I'm measuring my time not from T1 to this point. I'm measuring it from the beginning, this 0 point, all the way up to that point. But if you just wanted this gap here, the time here will be the same as just T1. Okay. Now, with that concept in mind, I hope you appreciated that. But all I was saying is the acceleration for an object free falling is going to be constant throughout, and the value will be negative 9.8. Okay, so of course, this is a velocity time graph, so I expect this to be time. I can say in seconds, and I expect this to be velocity. I can say in meters per second. And lastly, at this point, since I'm saying this is double t, so I expect the velocity here to still be v, but to be a negative value. So it will be the same as that, but just negative because now it is going downwards. Okay, so with that brief description, let's quickly look at a question that we can work out using some of the concepts we've described here. This extra bit about the graph, you only maybe find it helpful in some cases where maybe you have a quiz question And then, or maybe a multiple choice question, and then maybe they're asking you about this. You might find it helpful, or maybe you might not, but just covering all the bases. Let's look at an example. Let's have this question where we're being asked to say, or being told that the ball is thrown upwards with an initial velocity of 15 meters per second, and then it falls and is caught by a person who threw it. So here, since the person who threw it is the one who catches it, the assumption is that this ball goes up and falls back to the same point where it was thrown. So the assumption is that, let's just put this in place. Okay, so our assumption here is the object goes up from this point, it goes up vertically upwards to the maximum height, then it starts coming down. Since it's the same person who catches it, so expect it to, let's say it is caught at the same level where it was thrown. So that is that condition where we say we just double the time will help us here. So how do we work it out? Well, the first part the same. How high does the ball go? So we want to find how high. We want to get the height from the maximum point to where it was thrown. Or in other words, we want to get the height from where the projectile was thrown to the maximum height, or the turning point, in other words. So what do we know? Well, we know the velocity the projectile was thrown. At this point, the velocity was 15 meters per second. It was going up, positive. Then apart from this, at the turning point, the question doesn't say, because of the question, they don't tell us to say the velocity at the maximum height, what the turning point. They don't say a thing about that. But again, remember we say that at the turning point for a projectile, the velocity is going to be 0. So here I just want to focus on the projectile going up. I'm not looking at the full route. I'm just focusing on the projectile going up, because that's what I want to look at. So the displacement it is going to undergo, let me call that displacement S. This is going to be actually the distance that we're looking for to the maximum height, the displacement to the maximum height. Next up, the acceleration. Well, this is free fall, so our acceleration is negative 9.8 meters per second squared. Okay, with this in mind, I'm seeing that there is no reference to time among the details I'm given, neither am I looking for time just yet. So in part A, I'll pick an equation that doesn't use time or that doesn't require time. So that is going to be the third equation I wrote down. B squared is equals to U squared plus 2AS. So again, S here is my displacement. V is the final velocity, which is the velocity at the turning point. And U is the velocity the projectile was thrown with. A is my acceleration. In this case, it's due to gravity, so it is negative 9.8. S the displacement or the height from where the projectile was thrown from to the maximum height. The final velocity at the maximum height is 0. This projectile was thrown with 15 meters per second squared, vertically upwards, plus 2, multiplying negative 9.8, multiplying the displacement S. So here I want to find displacement, so I will make displacement subject to the formula. First, if I multiply this, I'm going to have 0 is equals to 15 squared minus 19.6. Then this is S for displacement. So now I want to make S the subject of the formula, so I hope you guys won't be confused. This is an S, not a 5. Okay, so I want to make S the subject of the formula, so this term can cross the equal sign. Now I have 19.6. Then this is equal to 15 squared. So working this out for S, so I can divide both sides by 19.6. So this becomes 15 squared divided by 19.6. So if you work this one out, we get S is equal to, when we perform the division here and square, then divide, we're going to get 11.5 meters. So this comes out as the height or the displacement to the maximum height. Now, after doing this, the second part, we're being asked to find, let's go back to the question, we're being asked to find, after 1.5 seconds, is the ball still going up or it is on its way down? So after 1.5 seconds, where is the ball going? Is it going up or is it going down? How do we work out that? Well, let's use this part here. To do that, again, let's look at what is happening. The ball goes up, reaches the maximum height, and then it starts coming down. Now here, since we're given the time, we know the initial velocity. Now, what you're just going to do is, we will just try to find the velocity after 1.5 seconds. So here we just say, okay, if we wanted to find the velocity after 1.5 seconds, so let's use u plus nt. Now, notice one thing about this equation. This equation keeps reducing the final the initial velocity. Since this is plus, negative 9.8. Let me keep this t for now. But what you see is that this is just 15 minus 9.8 t. Now, see what is happening. As you approach the final velocity, the turning point, the velocity is reducing. And by the time you reach the turning point, the velocity is 0. And then after that, the velocity becomes negative. So if the velocity is negative, then obviously this ball is coming down. But if the velocity is positive, then this projectile was still going up. This is a simple trick that we're going to use. So in other words, all we're going to do is, after 1.5 seconds, if t is 1.5, what will be the value of v? Will v be positive? If it will be positive, then we expect the projectile to still be going up. But if v will be negative, then we expect that this velocity, or this 15, has been reduced enough such that it has changed signs and now it is negative. In other words, if the velocity will be negative, the velocity will be fine, v will be negative, then the projectile is going down. So let's see how it goes. Well, after 1.5 seconds, now you have 9.8 multiplying 1.5 seconds. If we work this one out, we get the final velocity as 0.3 meters per second. And this is a positive value. So because the velocity after 1.5 seconds is a positive value, we conclude that this ball, the ball was going up. It was still going up. It was still going up. So again, we're concluding that the ball was still going up because we're seeing that after 1.5 seconds, this velocity was not yet reduced up to 0. I'm saying reduced because you're seeing that after 1 second, from 15, we're subtracting 9.8. So it's like with the changing time, we keep on subtracting from 15. At some point, we'll subtract such that this gives us 0. And for times greater than that, it means that the velocity is now a negative value, meaning the object is now coming down. I want you guys to try it for t equals to 2 seconds. See that the value of velocity you find will be a negative value, meaning that the projectile will be going up. This is another method that you could have used. Another method involved you finding the time it requires for the projectile to reach the maximum height. If it requires a time greater than 1.5, then you can conclude that, well, since 1.5 is less than the time needed to reach the maximum height, then the projectile is still going up. But if it takes less than 1.5 for the projectile to reach the maximum height, then you can conclude that, well, then after 1.5, the projectile had already surpassed the maximum height and it was coming down. Okay, now we've worked out part A and B. Let's quickly look at part C. For part C, easy. They're saying how fast is it going the instant before it is caught. So you can say before, or you can say just when it was caught. What was its velocity? Well, being caught means that we are here, exactly from the level point where it was thrown. And if you guys recall from our previous description, what we said is the velocity it is thrown with, it will be the same velocity, it will reach the same point it's on its way down. The difference is the sign. So if this projectile was thrown with 15 meters per second up, on its way down, this projectile will have the same value, but in the opposite direction, negative 15. So that will be the velocity it will have on its way down. So that's meters per second. Okay, lastly, D, what are they saying? For D, we're looking for what? Let's see. How long does it take? How long is it in air? So we want to find how long this projectile was in air? Well, to do that, all we need to do is, of course, there are a number of methods, but let's use one. Let's use this. Let's just look at how long it takes to reach the maximum height. And since it falls the same level, this is the part where we're saying you can just double this to get how long it takes altogether to come back to the same level. Since the time it takes to go up T1 will be the same as the time it takes to come back down T2. So I can just say T1, T1. So that to get the total time, I'll add T1 for going up plus T2 for coming down. But first, let's find that T1. So the initial velocity is that 15 meters per second it was thrown with. The final velocity is at the turning point, since I'm evaluating just T1 for going up, that's zero. The acceleration is negative 9.8. So now I want to find T, the time it takes to go up. So I'm just saying that's T1. So this is basic, so I'll use V is equals to U plus AT. So here I can say T is equal to final velocity minus initial over acceleration, so that my T1 will be equal to the final velocity, that's 0. Initial velocity is 15 over negative 9.8. So if we work this out for T1, we quickly see that T1 comes out as 1.53 seconds. So after getting T1, to get the total time now, just like you say, total time will be the time it takes for going up and coming down. But to go up, it takes 1.53. To come down again, it takes 1.53. So if you add this and this, you get the total time going up and coming down. But this again is only true because it is caught at the same level it was thrown at or from. If it was caught, let's say, somewhere higher, we wouldn't have used this method. Or if it maybe fell to a point lower, we wouldn't have used this method. But for now, we're saying it is caught at the same level. So meaning the total time T will be equal to just double that 1.53 seconds, meaning this comes out as 3.06 seconds. This becomes the total time of flight, or becomes how long this ball was in air. Okay, so I hope you guys were able to follow through this. This was just a introduction. We'll look at some more interesting questions as we go, but in the next tutorial, we're going to look at one interesting question. So we're going to look at the traumatic brain injury question. So if you guys want to see this, stick around. Let's see you guys in the next video. This was your tutor.